Okay, I'm getting a little faster. I'm only like 2 minutes late for the for the YouTube. Yeah, so right now, yeah, it's all like kind of meta. Like we are watching a stream of us streaming. Yeah, so there's always going to be like a slight delay. I try to do like the lowest latency possible, but it does create like a database of our whole semester, so you can always like rewind and go and look for stuff. And then if you're not in class, so I know like Wednesday, especially with the weather, like weather gets pretty crazy here in Connecticut for the winter. I know it's called the spring semester, but really we spend like 12 weeks of winter and 2 weeks of spring, and then we're gone. So be careful, keep yourself safe, keep yourself healthy. So if you're not feeling well, then you can always join online. Again, it's a different experience as you join online, but it's there. It is there. So my homework assignment for yesterday was kind of organizing the whole course based on the schedule, like kind of up until the last 2 weeks of the semester. And let's go month. Yeah, the calendar like drives me crazy because it won't show you the whole calendar. All right, so let's do due date. Then we can zoom in. First thing coming up is quiz 0. This one's a practice quiz. You can try it. You can do it as many times as you want. So the goal is like everyone has a 100 on this first quiz 0. And just so you kind of understand the process, because and I'll go through. I'll show you like how I would do it, and then you can do it however you want. But it's more of like how do we work on quizzes? How do we do that? Then we also I want you to like make a GitHub account so that you have access to discussion board, and then submit that first discussion post there. I'm not going to keep track. I mean, technically I will, because it's all like online, but I could go and see like how many times you read. I think you can see like who read and who didn't read. I don't know. The internet's weird. It keeps track of all sorts of metadata on what you do. But it doesn't count like towards your grade. So it's there as a resource, as a tool for connecting to each other. And then homework 0, that one's going to be, I guess I could call it like project 0, because really it's our first like Jupyter notebook. We're going to open up Jupyter, learn how to use NanoHub so that we have computational resources, and then do like a projectile motion kind of problem in Jupyter and Python. Sound like a plan? It is a plan. But
are we going to go over some of the Jupyter Python stuff before then?
No, you're on your own. Good luck. No. We're gonna like do it, open it up and do it together. So I won't throw you to the wolves of like computational work. Again, the goal is we're using like Python to make engineering easier. So like the goal, computer work is supposed to help you as an engineer make your work easier, not to become a proficient, like optimized programmer. There are some things that kind of go hand in hand. Like if it's more efficient and it runs faster, sometimes that helps you. Other times it's kind of like, it doesn't matter. Whether it took 2 milliseconds or 2 nanoseconds, it doesn't really affect me, or you, probably. I don't have a watch that's keeping track of like milliseconds of time that my computer spent. Well, I do. My computer does have that watch, but I don't check it very often because it really doesn't affect Doesn't keep me up at night. Not all the time. Sometimes it does, but that's me. So those are the first couple assignments, but then the rest of the semester is kind of laid out from there. So after we do those kind of intro stuff, then we'll jump into module 1 homework, start talking about concepts, reintroducing some physics concepts, vectors and Newton's laws, and then we'll build quiz 1 and then keep going from there. Rinse, wash, repeat, new concepts, new ideas, new problem solving methods. How's it going so far? That was the number one question that I got a couple of times after Wednesday, was like, what is the exact schedule of the class? Like, how am I gonna slot this into the semester? And this is it. So it's all laid out. Every assignment is built in. So I'm gonna scroll all the way. So after we get through all the way into April, kind of the last 2 weeks of the semester, we'll spend 3 classes looking at project 5. And in module 1, the first thing that we'll do is talk about the project for module 1. Is thinking about what are we going to do as an independent project. It's not set in stone. Like, you're not, if 10 weeks later you decide like, well, I was really interested in robots, but now that I've seen like what I can do, I'm more interested in like entomology. I want to look at bugs. I want to like figure out like, what does it take? What's the power required for flight of a bumblebee or something? Anyway, so that'll be like that first couple of days, and then the next week, submit whatever your final product for project 5. That, and the project that we're kind of building towards, it can be whatever format you want. I like Jupyter notebooks, and you'll have like 4 notebook projects that you could copy and kind of edit and turn them into a project if you want. If it's not something that you want to do, people have done like PowerPoint presentations, reports, just kind of like 3 or 4 page descriptions, intro, method, all that. Every semester I offer interpretive dance as a final project option. And every semester someone's like, I'm gonna do it, and then I never actually get the interpretive dance product. So maybe this is the year, maybe spring 25. That's the interpretive dance dynamics project. Maybe. See. Good goal for the spring. Cool. Again, no midterm, no final. It is we do have like scheduled final, but it's just because I kept canceling the final, and then I'm like, who's paying me to do this? Who's keeping track of whether or not I have a final room? I'm like, all right, it's fine. If there's like an audit of like, have you been using your classrooms effectively? Maybe then I'll start doing it. Cool. Pausing for questions or just general eruption. You don't know what you're doing. Yes.
I assume you're going to discuss more about NanoHub and how to Jupyter notebook.
Yeah. So I was going to do that like together of loading up NanoHub. If you want, we can. So like inside this homework 0 is a Jupyter and Python. There's a link, and usually this is how each assignment is kind of built out. Like a link to what the homework or what the thing is, and then a link to say like, all right, submit my work there. Again, there's lots of different ways to use Husky CT, but this is the one that makes sense to me. Folder, resource, submission. So if you click that link, you come to a website, and the website shows you a lot of information. So it talks about like what is Python, why Python. You can use it as a calculator, but all this stuff is all like it's all a static web page, so it's all HTML. But if I look at this rocket and say, hey, launch this onto Jupyter Hub, I'm gonna do like a new tab. Then it brings me to my engineering dynamics tool for NanoHub. Oh, and it's telling me that I'm not logged in. That's okay. I can click log. So if I try to launch it, it'll say, hey, you need to sign in. For me, I have like a NanoHub account. If you don't, then you would, I think we say sign in with a different account. Yeah. And then create an account. And the only tricky thing here is that the very first option says like, hey, there are institutional credentials, but UConn credentials don't work for NanoHub. So just ignore the fact that it is in the drop-down list, and then create your own. You can create your own username, make a password. I don't think they'll check your contact information. It is required, but if you want to, I don't know, if you have an online persona, like usually Bobby Drake is mine, like Iceman. But yeah, so we'll say Bobby Drake. And then we do need an email, but it can be your UConn email. So you can sign in with your UConn email, or you can use any email. So this research, like you'll always be able to have access to NanoHub. It's not like a UConn controlled thing. And they have tons of other tools and resources that you can use, even if you go into grad school or you go. I think the only thing that you can't do with it is you can't do computations and charge people for the work that you do with NanoHub. I think you can't make money off of it is the main stipulation, but you can always go and use it, and you can use it to help you make money, but you can't use it to make money. So it's free as in free beer. And like you can use it, you can enjoy it, but you can't start taking a whole bunch of it and then selling it to other people. Make sense? That's like a common open source sort of like, be cool, dude. We're giving away stuff for free, so please don't put it in your own thing and then start selling it to somebody else. All right, so all of that, let's say we did all that, and now I'm gonna log in. And then it brings me to my, it brings you to like a NanoHub page. So I'm gonna come back here and ask for it again. Now it says I'm logged in as Ryan Cooper, and I can launch that tool. And we'll do this again, like as we're gonna try the homework 0 work next week. So if you didn't follow along, I guess we also have, you can rewind this, watch it in 1/2 speed. Slowly loading. All right, and then we're into, and right now we're working on this like getting started with Python. So this is the same content, but now it's all like a running Python Jupyter notebook. So I can say 2 + 2, or I could say 2 + 3. Or I could say, this is what my kids like to do. They're like, what's 2 plus 3? And I'm like, 5. They're like, no, it's 23. I'm like, well, you would have had to claim that it's a string object instead of an integer, because I assumed when you said 2 and 3 that you were creating integer objects in this conversation. But you have to say, like, what's 2 plus 3? And then you get 23. Not impressed. You can totally, now you can talk like 6-year-old and 9-year-old language, because you can speak to a computer. Cool. So that's, now we got our interactive notebooks. We can do math, we'll do all sorts of stuff. Good. That was like a whirlwind, just aside or kind of tangent to. Yeah.
It's not really clear to me how we submit that. Do we have to download the Jupyter notebook and then submit it through that submission link, or is it just automatic through Nanopub?
No, nothing's automatic. So for the most part, Husky CT is all like PDF stuff. Okay. That's the thing that works for Husky CT.
Okay.
So
once we're done with the notebook, do it after that.
Yeah. So if this was the notebook and I'm like, okay, I changed the 2 and 2 to a 2 and a 3. Now I'm done. Let me submit it. Then at that point, I would say, like, let me get a print preview, and then that print preview, save it as a PDF. And that's the 2-step process. Yeah. Yeah. Nothing's easy. Nothing in life is easy.
Will it save our outputs too?
It does save your outputs. Yeah. So like right now, and that's the thing that I like about Jupyter, is that it shows you what the inputs were, what the outputs, and then even keeps track of like what you were trying to do. So if you have your own notes to yourself of like, all right, here I want to look at something, I'm getting close, but I'm just hitting an error. You can like make a little block of markdown text and say, this is what I'm trying to do. I don't know where I'm going wrong. So along that line, this is something that, as everyone left on Wednesday, I realized it's the weird part about my classes that is not normal. It's that if you get a grade, so let's say you turn in this and you get a 70, like there were errors or missing pieces or something, so the 70, you're like, no, I need at least an 85 because that's the number that I want. Look at the comments that you got, go revise the work, and then resubmit. So every homework, every project, the quizzes are just like a one and done. Like just turn in the quiz, and I usually drop like the lowest quiz or something. Yeah, usually drop the lowest quiz just so there's always something that happens for like those assignments. But the quizzes are the only one that you can't resubmit. And then the homeworks and projects, get a grade, look at the feedback, and see what you would improve. Usually there's like very pointed things of like, hey, go back here, whatever. You divided by 2, but that's just a type, like you shouldn't have done that. That's easy to fix. Sometimes it's more like conceptual, like, hey, you're using a definition for work, but you're saying that it's equal to momentum. Like work is not momentum. Where is this coming from? So there you might have to go back, revisit actual conceptual work. But yeah, revisit, revise, resubmit, and then there's no penalty for resubmission. It's just, you get the points, you get the points. Cool. Nobody asked, but also you probably wouldn't have known to ask. It's like, can I get points back if I got it wrong? It's like, yes, you can. Cool. Ready to grapple with some concepts, big picture. Okay. also helps me get to know who we're working with here. All right, Newton's laws. What are Newton's laws? These are, at this point, like halfway, half-ish, maybe 3/4 of the way through your engineering education. Newton's laws are like tattooed on the inside of your head. What are they? What are Newton's laws? You can look them up too. This is not like a quiz. Yeah.
F equals MA.
F equals MA. Which law is that?
2.
Number 2. What are the other ones? That's the one that we use, right? So that's law 1, or sorry, law 2. F equals MA. Yeah.
Every action has an equal and opposite reaction.
Every action is has an equal opposite reaction. Which one is that?
I think 3, maybe 1, I have no idea.
3, yeah, that one's 3. All right. Okay. Oh, yeah, we'll start here.
I think the first one is like the one where you have an object like moving will not change its course of motion unless it's acted upon by external force.
You agree?
Yeah,
Like-
also the present day at rest.
And it stays at rest. Yeah, so if you're at rest, you stay at rest. If you're in motion, you stay in motion, unless a force, there is an outside force acting. So motion or rest is only changed by force. Roughly like that. All right. So a force can like change motion, and really like this second law is kind of like describing momentum, that forces that a force will change momentum. Forces are always proportional to a change in momentum, but it ends up being F equals MA as long as we're not dealing with like rocket science, like the force is a change in mass. But even that, it's still F equals MA, works out pretty well. And then if you apply a force, there's like some equal opposite force. So everything is a cause and effect, right? Like we can always trace back whatever happened, we can always point at it and be like, oh, well, that happened because this force happened, and that force came from this object. So it's turtles all the way down. There's always cause and effect. So if that's the case, does anyone have an issue with Newton's laws though? Like at face value? Have you been like studying these and using them and you're like, these are fundamentally flawed? Not yet. Or maybe you are, but you don't want to share it yet. Yeah.
So like only shown on a macro scale, like you go like the really small particles that don't really apply, like quantum mechanics.
So they apply really well to anything that's bigger than about an electron. So even like neutrons, protons, F equals MA works really well. And the only time that doesn't work well is if you're like near the speed of light. Then you have to take into account like relativity. But you could still kind of say like, all right, well, F still equals MA, but A is now like a function of time and space. You know, like space is no longer this. Time and space are not independent quantities. Yeah, so that one, it's true. I don't have any experience like dealing with electron. Like, I mean, I've used like electron microscopes and stuff. Like I've done it before, but I'm not like, it's not intrinsic to who I am. Of like every day I wake up next to an electron and it's like, hey, this didn't follow Newton's laws. So it's a little wacky, but yeah. Okay. So there is, yeah, and there's a few things. Like it has to be less than the mass of a black hole. Like then Newton's laws still apply. It has to be more than about the mass of an electron. Has to be relatively short times, as in like not millennia. And then also, what's the last one? And then also not near the speed of light. So once you get to like 99% of the speed of light, then now Newton's laws are not. But that still covered, there's a lot of stuff still covered in there where it's still working. Still working. So no. All right, so if nobody has a big issue with this, where do we come in? Like, can you still have free will if everything is a cause and effect? Like if your world is this Newtonian cause and effect, are you still creating change? Are you like making decisions? Or is this all like some kind of domino effect? Like you're here in this class listening to this insane person all because it was predetermined. It's just, so that's my question for you. This one, let's take like 2 minutes or three, let's take like 3 minutes. Talk to people, talk to somebody next to you. There's usually 2 camps of thought, but I want to see where people sit. So take a minute. What do you think?
They govern everything but us.
So that's what we're trying to figure out. Yeah, some people start with like being defined as like going to that.
But yeah, I guess because if you then take it to apart like synapses, and they all contribute to each other. That's just like a laws you govern the world.
So you sound like the I can't joke.
No.
Is that a joke?
Like the limitation.
It has to exist for at least 8 years. Or actually and to get to this point right now. Yeah, and no longer showing calculate at people's NA when you're talking. What is time relative? If time is relatively different, we need extremes. Because you're always getting halfway. Yeah. You never get it. How do you How do you define it? That's an idea, that's not a position. So you're telling me I know. So you're telling me I can save energy by not touching anyone? Boom, free energy. I'm apparently. Is there really a
swimming against the current where you pushing around you get water on a mattress.
Well, what is it?
Yeah, it's like a metaphor. Still, so somehow free will's in there, but it's just not. I believe it was ME.
What is the joke? Now we're getting into
Alright, so we're gonna draw a quick line in the sand of just like, so if you're, some people come in and like they already had an idea of this before, other people are like, what the heck am I doing here, doing philosophy in dynamics class. So let's do a quick poll of, is anybody like in the camp of like, yeah, Newton's laws are laws, So there's no such thing as free will. Like it's just everything is cause and effect. We can do like thumbs up, rough. Let's see, so I think like around, I think we had like around 6, and then like kind of thumbs up. No, no way free will is a thing. More of like I'm an individual. There is free will. It's got to be free will. Is it the rest of the class? I mean, so I'd say like more than 20 are still here in like the free will camp of like Newton's laws. Yeah, they're good for some things, but not for me. I'm my own deciding free will sort of person. What came up? Did anyone not fit into one of these camps though? Like, were you on the fence a little bit? Yeah.
I think like on a microscopic level, there really is no free will. But at the end of the day, like if you had a computer big enough to predict every motion of electrons, then you could probably figure out what's going to happen in the future. But and everything comes down to no free will. But at the end of the day, I don't think it's relevant because we have no way of measuring it.
Okay.
Psychologically, because we have a conscience, we have a free will, and we can make our own decisions.
Okay, so yeah, like if we, and this was kind of like one of the ideas of like physics, and it's kind of this dogmatism in physics. So like dogmatism is in like we all sort of accept it, and we accept it because we all accept it, and like whether or not that works for everybody is kind of like, well, nobody asked, and so one thing that people kind of thought is like, hey, if I had the exact position of everything, of every atom in the entire universe, and I had the exact velocity, like its little 3-component vector velocity, then every problem for the rest of time, I would know exactly what's going to happen. Because if you have initial position and initial velocity, you know everything. Like you know what forces are acting, so everything is just gonna fall into your little like, well, not little, your like universe-sized abacus. You can just like flip, 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 flip. Let me go to next year. Oh, next year I'm gonna be like riding a bike in Florida, and the year after that, let me do something else. So that is like a dogmatism, and it's still there in physics. There's still this idea like, oh, if we find the fundamental forces, if we find how gravity and what is it? Gravity and Maxwell's equations. It's a big black hole thing. Gravity and relativity. Like if we can figure all that out, then everything is mapped out. Like we have the answer to everything. But maybe not. Yeah, maybe there is something still there. Was there, sorry, who else was sitting like in the middle? Or not wanting to? What about the free will? So we had more free will camp. Like who was there saying like, what were the conversations about like just, they're kind of like defending of like, yeah, cause and effect exists, but who cares? It's still free. Yeah.
Well, our group sort of determined that it's free enough for us. It's too much effort to really go through and find all the particles, and we're too lazy to do any of that. So we just decided that there is free will, and that's the end of the story.
Free will by, what would that be? Reducto de apathy, like reducing to, I don't care. Like, it's fine. Yeah.
I think like with free will, like we have free will. Newton's laws of govern how things in the universe like work and act, but like
we can choose what we do, but how that plays out is affected by like new stuff. Like I can't just walk up in the front of the room and start floating.
Yeah, there are certain things that we can't break. Yeah, floating is one of them. Because if you're doing something, like if you're flying, you need forces to overcome gravity. And if you have forces, and if you're flying upwards, like a force, now you need work done, work against gravity somehow. Like something, can't make something out of nothing. That's like the rules of thermodynamics. You can't make something out of nothing, and you can't win if you like sum them up into two: conservation of energy, increase in entropy. What about determinism? Does anyone have a rebuttal of like, you're all crazy, we're all sheep? Yeah.
Alright, so what he was saying about
Yeah.
how we kind of essentially live in a world in which it's always, those forces are always acting on us, but we're always in the Newtonian world. Technically speaking, we do have free will in which that we could always be doing whatever we so please. So he's saying, you go up there, go from the goal and just jump. You can't float down. You can
Okay.
jump.
But you could jump. Yeah.
But in the end, like, yes, you do have free will, but in terms of like, you're always going to be acting in a Newtonian world. Technically, don't free will. You just know what you could do inside the world.
Okay. Yeah.
That's how I think so.
Yeah. So there are things that you can do. You can make changes, but they're all the same cause and effect. Even though you made the change, it's still kind of moving along. Yeah.
So I'm kind of in the free will aspect, and I think
Yeah.
we're not spending enough time talking about how we're all kind of governed by subconscious actions sometimes.
Yeah.
I mean, there's a lot of study talking about how our habits and how we communicate are all kind of subconsciously guiding us.
Yep.
So, like, yes, the physical world is, following Newtonian laws, but how do we describe the subconscious that's not physical?
Yeah.
So,
Sorry, go ahead.
I mean, our choices are, derived from something in our brains.
Yeah.
So it's like, and all of our brains are unique. Sure, you could argue that, they're neural pathways, electricity or whatever, but like everyone's unique. How do you kind of put that in a bubble?
Yeah. And there, like recently, there's a book called Determined that's talking about that, about how the same kind of cause and effect exists in a lot of the way that we think. So your community, your history, the family, like all these things kind of build neural pathways and reactions. And this author's conclusion from that is like, because you can always trace decisions back through like neural connections, is that there is no free will. Like you have to give the person the benefit of the doubt of like, the reason they broke a law, the reason they made a choice was because it was already going to happen. I didn't really agree with the book. I was reading it and like, this is crazy. But it's that same idea of like, if everything is an effect of a cause, then if you can trace those causes back, then there's no room for choice, because you kind of pointed out all those causes along the way. Sorry, and I cut you off.
I was going to say the same thing you said.
Oh, sorry. Yep.
That it's mostly comes from your experiences.
Yeah.
And that what guides what choices you make. Like that subconscious comes from everything that you've experienced before.
Yeah. Yeah. So if you like that idea, this book called Determined it goes through a lot of like the neuroscience of like how choices kind of get embedded into your brain. Sorry, and then another.
I was just gonna say, like, you could easily trace everything back to your experiences, but I don't think you can perfectly predict what someone's going to do based on their experiences.
Yeah. Okay. And
so it's kind of like hindsight's 20/20.
Yeah. So Kant, in his like critique of pure reason, kind of he described as like if you had, and the metaphor is sort of like if you had like green sunglasses on, everything you ever saw would always be a shade of green, and you could create like all these beautiful images, and like there's still, the world is still like acting around you, but everything is only seen through green lenses. And for him, what he talked about was like an effect, the lens is cause and effect. You only see cause and effect. So if everything you see is always a chain of causes, then soon your brain is going to make sense of that as, oh, there's cause and effect. So forward, backward, I can make predictions because it's all cause and effect. But it's a limit to how we actually like process information. That was his like critique of this like idea. So that's where, for him, that's where free will came in, is that yes, this works and it's a great way for our brain to process information, but we can't even see the idea of not cause and effect because there has to be a cause and effect based on these lenses that we have. I don't know if that helps some people grapple with what they were thinking. All right, the quick wrap up for this, like why are we doing this? One is just get you thinking about how is this class actually applicable to like you and your life? Is this folding in, is this a tool that you're gonna use and it's separate from you? Or is this like totally something that it's now part of your world, like you're another cause and effect in this cog? And then next time we'll jump into like specifics of like how do we actually do this? Cool. Thanks a lot. Have a great weekend. You made it through the first week.